This video is going to be about torque as part of your fastener worksheet that you're going through. There are some questions about torque, and I wanted to give you a little background on what it is so you can get an appreciation for what it does and how to measure it. So first thing is get a good pen when you're going to do a video. So torque, what the heck does torque mean? A lot of times people will say, well, it's a force. It is a force, but it's different than I can apply a force to this whiteboard and lean against it, and that alone is not torque. What torque actually is the rotation. How hard are we twisting or rotating something? That's what torque means. This is part of a car that drives it, the drive line. Somebody taking and grabbing your arm, there's not torque applied until they begin to twist your arm. So we're going to be talking about rotation and how much effort we're putting into the rotation, how much twisting force it is applying. So that's a short but pretty concise explanation of what torque is, twisting force. In this case with fasteners, what are we doing with torque? Well, we're trying to hold something together. That's the whole purpose of a fastener. We don't want things to fall apart. So in our case, we're talking about cars. We're putting cars together. We're using usually bolts, nuts that have a screw thread on them. And everything has vibration. So if we try to bolt a car together and we don't apply enough twisting force or torque to the fastener, vibration will cause the fastener to loosen up. So believe it or not, all bolts, when they're installed, and the nut that's placed on these threads, when it's tightened or twisted down, torqued down, it's actually going to create enough pull or stretch on this bolt that it will cause the bolt, like elasticity, like the elastic waistband in your pants or clothing. We can pull this bolt and it'll stretch and yet come back. So that's elasticity, meaning it will return back to its original shape or dimension. So when we place twisting force and on this thread, it's going to cause this bolt to stop at the head, the bearing surface, and as this nut tightens and it comes up against whatever part that we're tightening, here's our bolt coming through, there's the head of the bolt, here's our piece of steel that we're trying to attach, and here is, we'll make that a little further or else we need more threads. Okay, so here's our metal, our first piece, here's our second piece that is threaded. So that as this bolt's tightened, it's going to pull down. At this point, the head's going to stop. It can't go any further into the material. Meanwhile, this part of the bolt right in here that's being threaded is going to continue moving downward, and this bolt's going to stretch right in this area right in here. We will see some stretch take place. We want to be at a certain limit of that stretch. We can over tighten it and stretch it too far, and now it's beyond its elasticity and it won't return to its normal shape. At some point it will tear in two. You'll stretch it in two, shear it off. So there is a formula that they figure out, and all fasteners will have a torque. So one of your questions will ask you about the bolt, given the size, how much torque should you apply? And that's just a lookup that you can do online or in the packet that's provided for you. So that's the idea behind it. We're going to stretch those bolts and put what's called a clamp load. How hard is this clamping? On this, in this case, these two pieces of metal to hold them together and keep them from vibrating loose. Then we can remove it and reuse it, and it'll still work for us. So that's kind of the story behind why we're using torque and what the purpose of torque is. So how do we know how much torque to apply? What did they just give us an idea of what, if I twist on it this hard, how much torque is that applying? It's actually pretty simple. The formula is the length of the lever. So we're going to have wrenches and levers involved in this. And I'll show you a torque wrench here in a few minutes. I'll just show it to you right now. And this is all calibrated, so this makes it easy. I'm just giving you the formula behind it so you kind of know what's going on. You don't need a fancy wrench. If you know what you're doing with the formula, you can figure out about how much torque you're applying. But we'll get to this a little bit later. Finish up. So if I have a basic fastener, we'll just give it a hex head. And right in the center where this rotates, that's where we're going to do our measuring to figure out how much torque we're applying. So we're going to just draw a basic wrench, come around that and back, and this wrench will fit over the outside of this bolt. And I'm going to put a small hole up here to attach. In this case, we're just going to use a string. Now we're going to hang a weight on that string. Now this, from this point where it rotates, the center of rotation, out to where we're going to apply our force, that's our length. So the formula that we're going to be placing these numbers into is torque value is equal to the length of the lever. I'm just going to leave it as length of the lever, times the amount of force. Let's drop that over. Times force. Okay. So here's our length right here. This distance from right here to the string or the wire that this weight is hanging on, that's the length of our lever. So that's where the force is being applied, is right here. So we know that's a specific length. So let's call that, let's just pick a number. Let's say it's 2 feet long. We're going to measure it in feet to start with. And we're going to say it's 2 feet in length. That's the length of our lever. Now how much force is being applied? We're going to measure that in pounds. This weight, we're going to make this pretty straightforward. We're going to say this weight is 100 pounds. So according to our formula, we have our length. We're looking for our force, and there's our answer right there. There's 100 pounds of force being applied 2 feet out from the center of rotation. So what's that give us? 2 times 100. 200. And we want to keep our, I'm going to move back and do this a little different here. I'm going to title it like this, 2 feet. So 2 feet times 100 pounds, we have 200 foot-pounds of force, of torque. So we're going to keep our labels. Okay, and that's how much torque we're applying. We can change this. Let's say that it is 50 pounds of force. So we're going to lighten the force by half. Keep the length the same of the lever, the same distance, times 50. We've now 2 times 50 is going to be 100. So we cut the weight in half, or the force in half. We ended up with half of the torque. Okay, and same with the lever. What if we shorten this lever up? Maybe we move the hole in here and we hang the weight, the 50-pound weight, we move it into this area. So now it would be 1 foot long, the length of our lever, and let's keep it at 50 pounds. Let's say we just move this 50-pound block over, excuse me, and hung it onto that string right there, or wire or cable. 1 times 50 is 50. 50 foot-pounds because we're measuring in feet. The unit we're measuring in this case feet, is going to stay in our answer. Okay? So I'm going to move a little bit over here, and that's 1 unit of measure, foot-pounds. So these 2 torque wrenches that I have here are both measured in feet or foot-pounds. Obviously one's a little bit larger. This will go up to 250 foot-pounds, and this goes to 100. Notice the length is longer. The lever's longer. So you're gonna get more torque applied. You can change what these will do is click. When I use them to tighten the bolt, when I get up to the torque that I want and I have set into the torque wrench, it will click. You'll hear it click. And that tells you, hey, you've taught the amount of torque up to what you want, stop at that point, and the fastener's properly tightened. What if we're working on something small, like a small gas engine, or bolts that are real small, or you're in soft material and we can't torque them to this amount, 200 foot-pounds, it would just break the bolt right off, strip the bolt out, meaning it just pulls the material around the threads out of the fastener. So in those cases, in the case of us in the shop, we use a different torque wrench, a smaller torque wrench, and it's measuring the length in inches. So let's move right over here. Let's keep the same torque is what we're talking about here. In this case, we're going to measure it in our length times force. But their length now is going to be measured in inches. Force is still the same, it's in pounds. So our lever, now that we were using over here, let's just transfer it over to this side. Same concept. There's our fastener, there's the center of rotation. Now let's say our length is inches. So let's say it's 10 inches. And let's say it's, let's hang 50 pounds on there. We can still put a lot of pounds on there if we want to. So 10 inches times 50 pounds is going to give us a total of 500 inch pounds. All right. So a different unit. Sounds like a lot, but remember it takes 12 inches to make a foot, so it's not going to sound as much if we change it over to feet. So let's use one of these for just an example. Let's go back to this one here and let's convert it over, because it's very simple to convert them back and forth, as you would if I said, how tall is this whiteboard, and you measured it in feet, it's going to be 4 feet. If I ask you to measure it in inches, it's going to be 12 times that, because there's 12 inches per foot. So 4 feet times 12 is going to be 48 inches. Same distance, just a different way of measuring, a different unit. So for example, in this case, we're going to use the same 50 pounds in this example that I wanted to give you, and convert this over to inches. what would 2 feet in inches be? Well, if there's 12 inches per foot, 2 of those is going to give you 12 plus 12 would be 24, and that's 24 inches times 50. That's going to be, if we pulled out the calculator, kind of worked it over in our head. The way I do this, if it helps you, is I would round this, I would change this to 100, because 100 times 24 is 2400. And what's half of 2400? Well, half of 24 is 12, so it'd be 1200 inch pounds. So 24 inches, which is this, let's say this is 2 feet long here, that's actually 2 feet. Let's do this, change this to 2 feet. From here to here, it is also 24 inches from there to there. So if we did the formula, it would equal 1200 inch pounds of torque being applied to that fastener. Now, 2400 is equal to 100 foot-pounds. Those equal each other. It's getting kind of messy here, but hopefully you've followed along and it's making sense. So that's how we figure out torque. That's how we determine whether we're going to use feet or inches, or we have that option. And I thought I would show you what the inch-pound torque wrench looks like. Now this is a different design. This dial has a needle on it, and you can read it as it goes up. So this is used differently. You still put the socket on it, place it on the bolt, rotate or twist it, and it gives you the amount of torque that you're applying on this needle. So it's just a gauge, it's moving, and you'll have to watch this torque wrench to know how much torque you're applying. There's another needle on there, so I can watch. One needle stays put, the other needle will move as I apply the torque, and when those two line up, I know that I'm at the torque, so I don't have to watch the numbers. Versus the other torque wrenches that I showed you, some people call them talking torque wrenches or clicking torque wrenches. Those I go by sound. I don't have to look at it. I can concentrate on whatever else I'm doing, and when I hear the wrench click, then I know that I've reached my torque. This is measured in inch pounds, so it's more delicate. It's going to be a smaller scale. We use these, as I think I mentioned, on the small gas engines, or in some case, transmissions. Automatic transmissions are very low torque amount because you don't want much distortion inside the transmission, and some of those working parts, they're made out of aluminum, so you can't get carried away and over torque things or you'll break them. So how to switch back and forth. If I change feet to inches, then I can convert from feet to foot-pounds to inch-pounds. There's a couple of questions on this assignment that want you to do just that. I'm going to give you the length of the lever, and let's say, for example, just pick an example of a 4-foot wrench and times, and I'm just going to pick 100 again, 100 pounds of force. So if I measure, this would be 400 foot-pounds of torque. If I needed to come up with the inches, multiply the feet. How many inches is that going to be? Well, it's going to be 48, and I multiplied it times 12 to get 48 inches. So if you're going from feet, there's 12 inches per foot, so you have to multiply every foot you have times 12 to get your answer. And the other way around, it works too. If I give you the length of the lever in inches, remember it takes 12 of those inches to equal a foot. Divide you can do your answer if you want, do the whole calculation and just divide your answer by 12, and that gives you the inch-pound torque. So I hope this is helpful. Nice thing about a video, you can play it back and see where I lost you or where I said something didn't make much sense. And some of this isn't left up here for you to look at. So good luck. Let me know if you have questions about it. And have a great day.